To find the resistance of a given wire using a meter bridge and hence determine the specific resistance of its material. A meter bridge or slide wire bridge is the practical form of Wheatstone bridge. If the resistance applied by the resistance box is R and no deflection in galvanometer is obtained at point B on wire AC, then length of wire AB is equal to L, length of wire BC is equal to 100 minus L, resistance of wire AB is equal to P is equal to rho L by A. Resistance of wire BC is equal to Q is equal to rho 100 minus L by A, or P by Q is equal to L by 100 minus L, where A is the area of cross section of the wire and rho is the resistivity of the material of the wire for a balanced Wheatstone bridge. P by Q is equal to R by S.
Madam, how can we find the resistance of a given wire?
We can find the resistance as follows. If the resistance per unit length of the wire is
sigma,
then resistance of wire AB by resistance of wire BC is equal to P by Q is equal to L
sigma
by 100 minus L.
sigma.
P by Q is equal to L by 100 minus L. According to Wheatstone bridge, P by Q is equal to R by S, or S is equal to QR by P, or S is equal to 100 minus L by L into R. Using this relation, we can find the resistance of the given wire. Let's do an experiment to find the resistance of a given wire using a meter bridge and hence determine the specific resistance of its material. Our aim here is to find the resistance of a given wire using a meter bridge and hence determine the specific resistance of its material.
Apparatus required
are a meter bridge, a resistance box, a galvanometer, a Leclanche cell or battery eliminator, a jockey, a one-way key,
a screw gauge,
a meter scale, a wire whose resistance to be determined and connecting wires. Procedure: first of all, draw the circuit diagram and then arrange the apparatus according to the assembly diagram. Now tighten all the plugs of the resistance box by pressing and twisting each plug. Clean the insulation at the ends of the connecting wires using a sandpaper. Connect the wire whose resistance is to be determined in the right gap between copper strips C and D. Connect a resistance box of low range in the left gap between copper strips A and D of the meter bridge. Connect a Leclanche cell and a one-way key between copper strips A and C. Connect a galvanometer and a jockey with the middle screw given at copper strip D. Apply some resistance, say 2 ohm, from the resistance box by taking out corresponding plug from the resistance box. Close the key K and touch the jockey gently at the left and then at right end of the meter bridge wire and note the direction of deflection in the galvanometer. If the galvanometer shows deflections in opposite directions, the connections are correct. If not, then check the connections of the circuit. Now move the jockey gently along the wire from left to right till a point is obtained where galvanometer gives no deflection. This point is null point B, and at B the bridge is in balancing position. Note the position of the null point B and record the length AB is equal to L. Take at least 4 such observations by changing the value of R and repeating steps 8 to 11. Cut the wire at the points where it leaves the terminals. Stretch it and find its length L. Measure the diameter of the wire at least 4 places in 2 mutually perpendicular directions at each place. Record all the observations in tabular form. Observations: length of the wire L is equal to x centimeter. Table for the unknown resistance. Serial number. Resistance from the resistance box R, ohm. Length AB is equal to L, centimeter. Length BC is equal to 100 minus L, centimeter. Unknown resistance S is equal to 100 minus L by L, R, ohm. Mean resistance S is equal to X ohm. Least count of the
screw gauge.
Pitch of the screw is equal to X mm. Total number of divisions of the circular scale N is equal to X. Least count of the
screw gauge
is equal to pitch by N is equal to X mm. Zero error of the
screw gauge
E is equal to X mm. Zero correction for the
screw gauge
minus E is equal to X mm. Table for the diameter of the wire. Serial number. Linear scale reading A, mm. Number of circular scale division coinciding N. Circular scale reading B is equal to N into LC, mm. Observed diameter D0 is equal to A plus B, mm. In any direction, in perpendicular direction, in any direction, in perpendicular direction, in any direction, in perpendicular direction, D1, D2, D3, D4, D5, D6. Mean observed diameter D is equal to X mm. Result: the value of unknown resistance S is equal to X ohm. The specific resistance of the material of the given wire is equal to X ohm meter. Percentage error in measured specific resistance is equal to X%. Precautions: the insulation at the ends of the connecting wires should be cleaned by sandpaper. All the connections should be neat, clean and tight. All the plugs in the resistance box should be tight. The jockey should be moved gently over the bridge wire and it should not be rubbed on wire. The key K should be closed only when the observations are to be taken. The resistance from resistance box should be selected in such a way that null point should be brought between 45 cm and 55 cm on wire. Set square should be used to note null point to avoid error of parallax. At one place, diameter of wire should be measured in 2 mutually perpendicular directions. Sources of error: the instrument screws may be loose, the plugs may not be clean, the plugs of resistance box may be loose, the wire may not have uniform thickness, the
screw gauge
may have faults like backlash error and wrong pitch.
Thank you, ma'am. This experiment has made the concept very easy to understand.